As if malls aren't bad enough, getting lost in one is the worst. Well, that could become a thing of the past because Robotera's Q5 is here to help. If you need directions to the movie theater, or want to get your shoes shined, or just want to hang out with pandas and act cute, Q5 is the answer. And say goodbye to ChatGPT because Q5 also educates your kids. And well, hey, maybe housework isn't your thing. Your home will be kept harmonious as Q5 is capable of taking on multiple household duties. And that gives you more time to do what's really important. Q5, where have you been all my life? Okay, so those are some applications, but how does Q5's operation work? Well, the slender robot features 44 degrees of freedom, including the highly dexterous X-hand light with fingertip precision and a 10-kilogram payload per arm. Equipped with 7 DOF arms for extended reach, the Q5 navigates autonomously using fused LiDAR and stereo vision and can also be remotely operated with VR and sensor gloves. It also provides all of these features and communicates naturally through an AI voice system with fast, context-aware dialogue. The robot marks a step forward in redefining human-robot interaction with lifelike performance and design. And if you need reliable parts for your design, check out our premier product highlight sponsored by Mouser Electronics next. Teledyne Relays SHC Series AC output solid-state relays are single-phase relays designed for industrial use. They feature up to 100 amp output, LED status indication, and a built-in varistor for transient protection. They support resistive, inductive, and capacitive loads with zero cross or random turn-on switching. The SHC series uses direct copper bonding technology and includes IP20 clip-on covers and self-lifting terminals. With up to 1400 volts peak blocking voltage, they offer reliable, high-performance switching from 45 Hz to 65 Hz and are ideal for phase control applications. Check out these reliable relays at Mouser.com today or by clicking the link below.
Did you know that not all circuit breakers are created equal? Well, we know that the current capacity is the main rating for a circuit breaker. Some of them can be 1 amp, 2 amp. Maybe in your house there's 15, 20 amp circuit breakers. But there's something even more important in industrial devices that often gets overlooked, and it's the purpose of the circuit breaker. The curve, which is a rating on the circuit breaker, tells how quickly it will trip under certain operating conditions. In industry, we have a lot more inductive devices. Those inductive devices, especially motors, they start up, but they take a lot of current while they're starting. That means that while they might operate with only a certain number of amps, say 10 amps, while they're getting started, they might be expected to take 15, 20, or even higher numbers of amps. So if that circuit breaker tripped immediately when it saw 15 amps, it would trip every time the motor starts. So we have to understand breaker curves, and there's a lot of them, and lots of tables to be able to look up those ratings, but we have to understand how those work before we choose the right circuit breaker, especially for inductive devices and different load ratings for industrial motors. Andy, back to you.
Are you a smart byte or smart bit? Let's find out in our control automation quiz, Smart Bit. Okay, in our Smart Bit quiz, you must match the right answer to its question in less than 3 seconds. The questions are scored using actuator output percentage, and today we'll be testing your knowledge on a warehouse-picking humanoid robot named Gabby. At the end, you'll see if you're a smart byte or smart bit. Let's begin with our first Gabby question for 25%. Gabby's task is to pack a plush cat. To identify the cat among other soft toys, which method yields more robust detection despite deformations and inconsistent lighting? Is it A, color histogram matching with template correlation, or B, deep learning-based object detection using a trained convolutional neural network or CNN? And the answer is B. Deep learning-based object detection using a trained CNN. CNN-based object detection handles deformations and variations better than template methods, especially in cluttered or inconsistent environments. Okay, let's move on to our next question for 25%. After identifying the plush cat, which approach ensures a successful grasp without deforming or dropping the toy? Is it A, real-time grasp point estimation using depth data and soft body modeling, or B, predefined grasp points based on CAD models? And the answer is A, real-time grasp point estimation using depth data and soft body modeling. The plush cat's shape is unpredictable. Real-time depth sensing with soft body modeling adapts to its flexible geometry for secure gripping. Okay, let's go on to our final question worth 50%. Gabby managed to grab the cat. Now Gabby must place the plush cat into a box already partially filled with other items. Which control strategy ensures correct placement without collision or misalignment? Is it A, fixed drop height and location assuming an empty box, or B, vision-guided placement with collision avoidance path planning? And the correct answer is B, vision-guided placement with collision avoidance path planning. Vision-guided placement lets the robot evaluate current box contents and adjust its trajectory, avoiding misplacement or damage. Well, how did you do? Are you a smart bite or bit? You can have another go at it right now by clicking the link on your screen. Thanks so much for tuning in, and we'll see you next time.